Let's begin with question 5 now. In problem 5, there is a quadratic equation. Let me first explain you the question. So this is a quadratic equation. We are looking for real roots. That is, we are looking for alpha square is equal to 4 beta. And what are alpha and beta? Alpha and beta are the number of probability. Alpha and beta are the number of heads, right? When C1 is tossed. And beta is number of heads when C2 is tossed. So C1 and C2 are two coins. They are biased. 2/3 की प्रोबेबिलिटी से हेड आता है C1 में और 1/3 की प्रोबेबिलिटी से C2 में हेड आता है. तो इनको दो बार टॉस करते हैं. तो देर इज अ प्रोबेबिलिटी दैट अल्फा, कुछ प्रोबेबिलिटी है कि अल्फा 0 आए, अल्फा 1 आए, अल्फा 2 आए. लाइकवाइज फॉर बीटा, व्हाट इज द प्रोबेबिलिटी दिस विल गो टू 0? दिस इज द क्वेश्चन. सो इफ दिस इज सिंस अल्फा एंड बीटा बिलोंग्स टू 0, 1, 2, क्योंकि दो टॉस करेंगे तो या तो 0 हेड आएंगे या 1 हेड आएंगे या 2 हेड आएंगे. When alpha is 0, we know that beta is 0, right? When alpha is 1, there is no possible beta. When alpha is 2, तो ये 4 beta is equal to 1. So these are the only two cases. 0 का मतलब है कि दो बार टॉस करें और दोनों बार ही हेड ना आए. तो पहली बार भी हेड ना आए और दूसरी बार भी हेड ना आए. साथ ही साथ C2 जिसकी 1/3 प्रोबेबिलिटी से हेड आती है, तो दोनों में ही टेल आए. तो टेल आ जाए और टेल आ जाए, राइट? सो इट इज 4/81. सिमिलरली दिस इज व्हाट हेड हेड एंड दिस इज हेड टेल या टेल हेड. एक हेड चाहिए तो ऐसे ही आएगा, हेड हेड. सो 2/3 इंटू 2/3 और हेड टेल, तो हेड आने की प्रोबेबिलिटी 1/3, 2/3 एंड सेम 2/3 इंटू 1/3, राइट? तो इसको सॉल्व कर लेते हैं. 4/9 इंटू 4/9 दैट इज 16/81. सो इफ वी ऐड these two, 20/81. So this is the probability of we obtaining a what you call real and equal roots to it. So this is easy to moderate problem. Students must have not found any difficulty in solving it. तो अब 6 की बारी. So now question 6 is we are being given a curve that is 2 sin 2x, right? And x lies between 0 से pi/2. So this is pi/4. So now a rectangle is being inscribed in this region. We have to maximize the perimeter of this rectangle. Now if this is alpha comma 0, this is certainly alpha comma the curve 2 sin 2x, 2 sin 2 alpha. From symmetry this has to be alpha, so pi/2 minus alpha comma 0, and so as this one. So perimeter is what? Now let me write this one also. Pi/2 minus alpha and 2 sin 2 alpha. Now perimeter is twice of pi/2 minus 2 alpha, right? And twice of 4, that is 4 sin 2 alpha. Now we need to differentiate it in order to maximize, as the question says. So 0 minus 4 plus 8 cos 2 alpha equals to 0. Hence cos 2 alpha is equal to 1/2. Since alpha lies from 0 से pi/2, so 2 alpha lies from 0 से pi, hence the only solution that we have is pi/3. Alpha is equal to pi/6. Just to be double sure, p double dash is going to be minus 8 sin 2 alpha. If you were to put this one, this turns out to be negative. And if it is negative, then it's a case of maxima. So indeed, we are getting maxima at pi/6. Now area, finding out area, plugging in the value of alpha and finding out area is not a big deal. So I rate this problem as easy. Let's begin with 7th question. Now this is a little typical question, conceptual one. So the question is that we are being given fx, right? This is your fx and g is any arbitrary function. Now fg, that is the usual product that they have given, and now let's pick a choice. So we have to understand it choice by choice, right? A choice. If G is continuous at 1, so G1 is limit x approaching 1, G1. This is what is given, right? G is continuous at 1, then Fg is differentiable. That's a claim. So if we were to talk about this is fx into gx, so what is h dash of 1? It is limit h tending to 0, f of 1 plus h, g of 1 plus h minus f of 1, g of 1 by h. Now f of 1 is clearly 0, right? So this is h tending to 0. F of 1 plus h is 1 plus h ka square, right? Sine of 1 plus h. G of 1 plus h, whatever it is, by h. H gets offset and we are being left with limit h tending to 0. Now you should be you should understand this. This is non-zero, right? This is tending to 1 plus sine 1, right? G of 1 plus h. Now our claim is, now we have to understand this, that they are saying if this is true, then fg must be derivable, right? So this is some value g1, let's say. So does this limit exist? This is tending to some value. It does exist, right? It does exist. So the claim is correct. Did you get this one? All the questions are similar. Let's talk about the second choice. If fg is derivable at 1, then g is continuous. Now fg is this. Now they are saying this exists. This exists. Then they are talking about that g is continuous. Now I am telling you that this exists. This exists. So does this mean that it is continuous? It only means that this limit exists, right? Because this is non-zero, right? तो ये भी एक फाइनाइट चीज होगी. तो ये इससे केवल ये पता लगता है फ्रॉम बी चॉइस, हमें केवल ये पता लग रहा है कि h टेंडिंग टू 0, g ऑफ 1 प्लस h ऑल्सो एग्जिस्ट. केवल ये पता लग रहा है. इससे ये कहाँ पता लग रहा है कि दिस थिंग इज ट्रू, कि ये जो वैल्यू ये i5 6 वो g1 के बराबर ही आएगी. नहीं पता लग रहा है, राइट? हेंस बी चॉइस इज रॉन्ग. ठीक है, सी चॉइस पे चलते हैं. सी चॉइस क्या है? इफ g इज डेरिवेबल, तो g डेरिवेबल है, तो इसका मतलब ये हो गया कि g ऑफ 1 प्लस एच माइनस g1 बाय एच लिमिट h टेंडिंग टू 0 इज l. ये एग्जिस्ट करता है. देन fg इज ऑल्सो डेरिवेबल एट x इज इक्वल टू 1. तो देखते हैं fg भी डेरिवेबल होगा. तो fg का तो डेरिवेबिलिटी यही आ गई. लेट्स इट विल फ्लो लाइक दिस ओनली. सो वी कम ओवर हियर. ठीक, अब ये बताओ ये एग्जिस्ट कर रहा है. दिस इज टेंडिंग टू 0, so certainly this is tending to 1. So this is clear from C choice कि limit मतलब it has to be continuous. ये हमें वैसे भी पता है कि अगर G डेरिवेबल है तो वो continuous होगा, तो हमें ये चीज पता है, राइट? अच्छा, तो इसका मतलब है कि ये एग्जिस्ट करता है. ये एग्जिस्ट करता है, ये 1 प्लस साइन 1 को टेंड कर रहा है, तो ये तो लिमिट एग्जिस्ट करेगी करेगी. मैंने कहा ना सारे चॉइसेस सिमिलर टाइप्स हैं. तो सी चॉइस साउंड्स गुड. मैं एक और बार समझा देता हूँ. हमने एक सी चॉइस में क्लेम किया था कि जी डेरिवेबल है, तो जी डेरिवेबल है तो वो कंटिन्यूअस है, तो ये बिल्कुल फर्स्ट चॉइस ही तो बन गई. अगर ये कंटिन्यूअस है तो ये जो लिमिट अपने पास h-1 आया था, तो ये चीज निश्चित है ना कि ये तो 1 प्लस साइन 1 जा रहा था, तो ये एग्जिस्ट कर रहा है. तो 1 प्लस साइन 1 इंटू समथिंग एग्जिस्ट करेगा ही करेगा. तो सी चॉइस सही हो गई. डी चॉइस देखते हैं. डी चॉइस में एफ जी इज डिफरेंशिएबल एट 1, देन जी इज डिफरेंशिएबल एट 1. अब वही वाली बात, ये एग्जिस्ट करता है, इट इज गिवन टू यू, इट इज गिवन टू यू, दिस इज नॉन जीरो. सो व्हाट डज दिस इन्फर? इससे हम ये इन्फर करते हैं कि लिमिट h टेंडिंग टू 0 g ऑफ 1 प्लस एच इज l. ये एग्जिस्ट करता है, यही तो इन्फर करते हैं. दे आर सेइंग इट इज डेरिवेबल. जब हम सेकेंड चॉइस में आए, सेकेंड चॉइस और फोर्थ चॉइस देखें, तो हमने सेकंड चॉइस को ही गलत कह दिया था. हमने कहा था कि इट इज नॉट मैंडेटरी फॉर इट टू बी कंटिन्यूअस. जब कंटिन्यूअस होना ही मैंडेटरी नहीं है तो डेरिवेबल होना मैंडेटरी कैसे होगा, इसको ऐसे ही समझ लो. तो डी चॉइस इज रॉन्ग. Correct. So in my view, since this is a quite conceptual problem, it is a tough problem, and I am very much sure that not every student, yeah, rather I should say it like that, most of the students must have not scored in this question. Let's start with 8th question. Here M inverse is adjoint of M. As we know, adjoint of adjoint M is n minus 2 M inverse. Now the order is 3, so M inverse into M, right? Now if you were to take determinant, so this is determinant M, now this is determinant, right? This comes out M cube, so this is determinant M, this is 1 by M, and hence determinant M turns out to be 1. So if determinant M turns out to be 1, M inverse is equal to M, that is M square is equal to I. You can formulate many choices like that. So that's your C choice, that's your B choice. Now coming to D choice. Now D choice says adjoint M ka square. That is nothing but adjoint M whole square. Now what is M square? That's I. Adjoint of I is I. Correct? So D choice is also right. Now this is a moderate problem, I would say, not a tough one. But yeah, a student might get stuck over here. That is, he should know that this is the deal. Else it will become little difficult if we were to prove this one as well. Now let's discuss question 9, that's on complex number. In this question, we were given modulus of z square plus z plus 1 is 1. And then we have to find some bound on z plus half. Z plus half reminds us of perfect square, so that is the thing, right? 3 by 4. So this whole modulus is equal to this. Now we know that this thing is always z plus half ka whole square plus 3 by 4. This is of course 1 minus 3 by 4 z plus half ka whole square, and hence we get z plus half ka whole square is greater than 1 by 4, hence z plus half ka mod is greater than equal to half. So that is your third choice, and A choice is of course wrong. Now we need to find the upper bound on mod z. So what we can say here is z square plus z plus 1 is always greater than mod z square minus mod of z plus 1, right? I need to find an upper bound. You should have this idea that x square plus ax plus b less than equal to 0, then you will get an upper bound on x, right? So this is why I am forming this inequality. अब इसका मैक्स क्या होता है? mod z plus mod 1. तो अगर मैं मैक्सिमम घटा रहा हूं तो ये और छोटा हो जाएगा. So we can then say that this is mod z minus 1 and this is of course 1. So what do you get? Mod z square minus mod z minus 2 less than 0, mod z minus 2 mod z plus 1 less than equal to 0. So mod z belongs to what? Minus 1 say 2. Of course it cannot be negative, so let's revise it. 0 say 2. So that's what the choice is, right? Second choice, that mod z should be less than 2. I regard this problem as a tough one because applying triangle inequality is not all that easy. Let's begin with question 10. Now question 10th, as you can see, is from SOT, and what does it states? I won't get into this XYZ because while studying also and while teaching also we are more acquainted towards XYZ ki jagah ABC. I don't know why JEE always take help of XYZ, maybe just to confuse the students or to check them. So tan x by 2, that is tan a by 2 plus tan c by 2 is equal to 2b upon a plus b plus c. Let's apply the formulas and then some relations are being asked. Delta s into s minus a, delta s into s minus c is 2b upon 2s. So S gets cancelled off and we are left with delta S minus A, S minus C, and in LCM 2S minus A minus C is B, right? This is just B. We can observe that this is also B, so this also gets cancelled off. So delta, right? Yeah. So delta, now what is delta? Rather, let me multiply S into S minus B up and down. So I am going to get S minus A, S minus C. This is equal to 1. This gets cancelled off. This is delta square. So S into S minus B upon delta is 1. That is tan B by 2 is 1. So this implies that B by 2 is pi by 4, right? Hence B is pi by 2. So angle B is pi by 2. So A plus C is also pi by 2. So does this helps us? Yeah. That's your second choice, B choice, right? Okay. Now C and D. D choice, if you were to look at, is x square plus z. Let me get into ABC only. A square plus C square minus B square is AC, right? This is plus C square. This is AC. Now this is some crazy relation that we are getting, AC, yeah. So let's forget about it because we have only obtained right angle triangle. Now, if I were to talk about tan A by 2, so tan A by 2 is delta upon S into S minus A. Now, since it's a right angle triangle, let me plot it again, ABC, correct? Now, what is your delta? Delta is half A into C. What is your S? S is certainly A plus B plus C by 2, and S minus A is certainly B plus C minus A by 2. By 2 gets cancelled off. We are left with AC, B plus C ka whole square minus A square. So this gives us twice AC upon, just open it, B square plus C square plus 2BC minus A square. Correct? Now, applying Pythagoras theorem, B square is equal to A square plus C square. So, what is your A square? What is your A square? B square minus C square. So, let me apply B square minus C square. So, you're going to get 2C square plus 2BC upon 2AC. So, this means C gets cancelled off and 2 gets cancelled off. You get A upon C plus B. So is this a choice? Yeah, C A upon B plus C. So this is your third choice, right? So this is a direct application of the formula. I don't think so students will get stuck in it, and I will rate this problem moderate. Let's begin with question 11, that is on vectors and 3 dimensions. Now what is the problem? The two lines are given, L1 and L2. The point of intersection is also given, 1, 0, 1, as you can see from the symmetric line. This vector is given, -3, -1 and 1. And this vector is also given, rather this is the line 1, 1, -1, 3 and -3, -1, 1. Now they are asking a line 3 which is an acute bisector. Now according to the drawing, this is the acute bisector, but let's take the dot product of it. -3 plus 1 plus 3. Yeah, indeed it is positive. So luckily I have drawn the figure correct. So this vector is nothing but this cap plus this cap, since they are of same magnitude. So this vector, line vector, is nothing but, let's add these two, -2i cap, -2j cap plus 4k cap. Hence, the equation of angle bisector would be this, right? Upon -1, and 2. Now, since we want to compare with alpha line L which is given, here it is y -1. So, we need to get a point in which the y coordinate is 1. So, what is the general point here? 1 minus lambda, 2 lambda plus 1, right? So minus lambda is equal to 1, hence put lambda is equal to minus 1. If you were to put lambda is equal to minus 1, you get 2, lambda is equal to minus 1, you get minus 1. So this equation can be rewritten as x minus 2, y minus 1, z plus 1 upon minus 1, 2. Again, if you were to look at that one, the denominator of z minus gamma is minus 2. So let me have this one. Now this is in perfect shape. You can just equate with it and can get alpha is equal to 2, L is equal to 1, and M is equal to 1, gamma is equal to what, minus 1, and yeah, that's it. And then just check the values. Now this is an easy problem and students wouldn't find any difficulty in it.